What's up, everybody, and welcome back to another video from the Scale It Learning channel. Today, we are doing something brand new, which I'm very excited about. We are looking at the IB Math Analysis test from 2021. This is going to be my brand new foray into this test. I've never even looked at it. I've never seen it before. We're going to have some fun right now and jump through all these questions piece by piece. And we're going to see what this test is all about as I plan to learn more and more and get an expert viewpoint of this entire exam as we go forward. Okay, without further ado, let's get into it. No timer here. We're just going to go through it just for fun here. All right, so first of all, it says the graph of y equals f of x for -4 to 6, that's the domain, is shown below. Here we're going to write the value of f of 2. So f of 2, that means what is the function value when x equals 2. So we're going to look up at this graph. I'll highlight it here so you can kind of see. It's a little thick here. We're going to highlight it like this. We got this is my function. And what is it right here when x is equal to 2? Well, the function value is 6, right? We can see it right there. And so my answer to this one is 6. Next, we want f of 2. So what is this? This is function composition notation. So I like to rewrite it as f of 2 like so. And then the way we basically answer something like this, we go inside out. So first I'm going to say, what is f of 2? Well, we already know that f of 2 is 6. So since this is 6, this is essentially the same as what is f of 6. Now we're going to look at 6 here on the x-axis and say, what's the corresponding function value at 6? And that is -2. So the answer right here is -2. That's how you do it done. Now let's move on to B. It says, let g of x equal this. On the axis above, sketch the graph of g. So they're saying g of x is 1/2 f of x plus 1. What are we doing? We're talking about transformations, right? So what are the transformations that are happening here? First and foremost, when you're multiplying the entire function by 1/2, it's a vertical compression, okay? So every point right here on the y-axis, like right here it's 4, it's going to become half of that, which is 2. Then at this point up here at 6, it's going to come down to 3, so on and so forth. But then we have a vertical transformation up by 1. So we're going to kind of play this out as follows, right? So we're going to say like this chunk right here at 4, that's going to come down to 2. But then we're going to apply a vertical shift up by 1. So it's going to eventually settle at 3 here like so. Let me fix that without an arrow. And then we got a nice line there. That would be part B, the first part. And then what about this stuff? It's all going to be the same thing, right? If we look at this graph, essentially everything is going to be shifted down almost equivalently. But we've got, once again, this is going to be taken by half to 3 and then shifted up to 4. And it's going to be like this. But it's not going to be the exact same shape because everything is compressed. So it should be a little flattened out. So we got that point right there. That's a good one. This point, again, is going to be brought down to 2, moved up by 1. So that's going to be at 3. And then the 0 is going to stay 0, right? Half of 0. Oh, no, sorry. Half of 0 is 0, but then we still shift it up by 1. So that point's going to be up here. And then this last point, we're going to take half of that, which is -1. And then we're going to shift it up by 1, and that's going to go to 0. So now we can kind of get a rough sketch. I'll do actually a highlighter so it's a little easier to see, but it's going to kind of go bloop, 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 curve it around, and that's how you do it done. Okay, so for this question, it says the eighth term in this arithmetic sequence and the sum of the first 8 terms is equal to 8. And this is a very interesting type of question. I haven't really done one like this before. And I'm just checking it out on the fly, so we shall see. And it says, find the value of the first term and find the value of the common difference. Okay, I'm going to start off with my arithmetic sequence formula, which is going to be u sub n is equal to the first term plus my common difference times n minus 1. And I know the 8th term is 8. And then my summation formula, is going to be, it's the first term plus the 8th term over 2 times n, right? You basically, and actually we know what n is, my bad. N is 8. So you basically average the first and the last, divide by 2, and then multiply by n, multiply by the number of terms. So I imagine now we can kind of use all of this to figure out what U1 and D are. Okay, so right off the bat, and we got a little system of equations here. I know the 8th term, so I can plug in 8 here. And I know that n is 8 as well. So we can say 8 here. And I know that this would, if I'm doing the 8th term, right, I can actually say this is u sub 8. But I know what u sub 8 is. It is 8. Okay, so we can do a little plug and chug here. And now we've got this really nice system, and we can start to solve. So the first thing I'm going to do, I'm looking at this equation. Again, I'm just looking at this in real time. I hadn't even seen a question exactly like this before, but you can see in this equation, oh, by the way, this is going to be sum of the first 8 terms. I know what this is too. This is 8. So I'm going to do a little plug and chug here, and I've only got one unknown in this second one. This one I have got 2 unknowns. But I'm going to always start with the one with the less unknowns because this is a single variable equation I can solve as follows. We're going to divide both sides by 8 first, and that's just going to get rid of this, right? We don't divide this by 8 as well because this is one singular term. 8 divided by 8 is 1 is equal to u sub 1 plus 8 over 2. Then we're going to multiply both sides by 2. We got 2 equals u sub 1 plus 8. Last but not least, we're going to subtract 8 from both sides, and we got u sub 1 is equal to negative 6. All right, so we got the first part. It said find u1. Now we want to find the common difference. Well, now I can plug this in here, and then we can find the common difference. So I now know that 8 is equal to u sub 1, which is negative 6, plus d times 8 minus 1, which is 7. Now we're going to add negative 6 to both sides. We got 14 is equal to 7d, or d times 7. Last step, divide by 2, divide by 7, excuse me, and divide by 7, and we've got d is equal to 2. And then we got our answers. Now, just for fun, let's think about this. Does this make sense? Well, with the common difference, we have negative 6. The next term would be plus 2. That's how the common difference works for an arithmetic sequence. So negative 4, negative 2, that's the third term. 0 would be the fourth term. Then we got 2, 4, that's the sixth term, seventh term, and eighth term. And as you can see, the eighth term is indeed 8. And the sum of these 8 terms is indeed 8 because if you look at these first 7 terms, they're all opposites, right? Negative 6 and 6, 0. Negative 4 and 4, 0. Negative 2 and 2, 0. And then 0 plus 8 will be 8. That's how you do it. Done. A research student weighed lizard eggs in grams and recorded the results. The following box and whisker diagram shows a summary of the results where L and U are the lower and upper quartiles, respectively. And this is a standard box and whisker plot. Just so you guys know, I'm going to write in a couple things here. This line right here is going to be our median value. This is going to be my max at the end of these little whiskers, and this is going to be my min value. And then, just like I said, this is the upper quartile and lower quartile, which we don't know. All right, let's read this. It says the inner quartile range is 20. The inner quartile range is this length. That's what they're talking about. So they're saying that is 20. Okay, now it says find the minimum possible value of u. Okay, let's think about this for a second. Theoretically, okay, if we got a max of 75 here, and we know that the median is 40. Now, I guess, let me think about this. Is it possible, because if we're trying to do the minimum possible value of u, we know u has to be above 40, okay, because there's no other way that we're going to get a median of 40 if u is below the median, right? So let's say we're going to have a bunch of values in here. With a median, half of them will be below 40, and the other half will be above 40. But it didn't say how high above 40. Okay, so let's see this. If there's any other conditions here. So the interquartile range is 20, and then if this would be, if we said that u would exactly be 40, then that L would be 20. And I guess it could be 40, right? The upper quartile value, it could potentially be 40, even though it looks like, hey, there's distance here. Theoretically, if we have more than half of the values are 40 and then the rest are down here and the lowest value would be 20, this is viable. So I would say the lowest we could go with u would be 40. If we go below 40, then that would disrupt the median and that would be an issue. All right, then it says, hence, find the minimum possible value of L. Okay, so this is a little different. Oh no, this is actually right in concert with what we said, right? If the interquartile range is 20 and you would end up being 40, okay? If the distance between the upper and lower is 20, the lowest it could be is 20, and we can't really get below 20. So there you go. That's how you do number 3. Done. Consider the functions f of x equals negative x minus h squared plus 2k, and g of x equals e to the x minus 2 plus k, where h and k exist in all real numbers. And first it says find the derivative. Okay, so we're finding the derivative of f. So let's take a look here. Looks like we've got a constant. When you take the derivative of a constant, that's just going to go to 0. What about this? Well, we can do a little bit of chain rule, right? I've got something to the second power, this whole expression. So we're going to use the power rule as part of the chain rule. And that means we're going to bring that exponent down to the front, okay? And then we take the exponent of 2 and we subtract it by 1. 2 minus 1 is, of course, 1. So I can just leave it like that. And then times the derivative of the inside. But the derivative of negative h, since h is a constant, is 0. Derivative of x is 1. That's it. We multiply by 1, but that's going to keep it as is. So there's our derivative. We got it there. Now it says the graphs of f and g have a common tangent of x equals 3. Okay? Or have a common tangent x equals 3. Excuse me. Okay, so then because of that, it says show that h equals e plus 6 over 2. Okay, well, let's do this. Okay, if they have a common tangent, let's first start. And I assume, so that means that at 3, they would both have the same point, I guess, because it has it would have the same slope. It is possible that like we could have a function here at 3. No, they'd have to intersect at 3 as well, because in order to have a common tangent, it would be something like this. Okay, I don't even know. Like this one, that's not exactly what the graph looks like, but this is a quadratic negative, so it's going to be something like this. This is e to the something, which is going to look something like this, right? So what we can say from this description is probably we're going to have a common tangent coming right through like this. Okay, so now let's see if we can figure this out. The first thing is when x is equal to 3, these two things should be equal to each other. So I'm going to plug 3 into the original functions. So I know that negative 3 minus h squared plus 2k, that's f of x, is going to be equal to g of 3, which is e to the 3 minus 1, which is 1. I mean 3 minus 2, which is 1. So that's just e plus k. Okay, so we have one equation with two unknowns. System of equations is what we need, right? Two unknowns, we need two equations. Well, again, as I mentioned, that if they have a common tangent, they must have a point of intersection, and that common tangent is going to share the same, right? It's got the same slope at that point of 3. So I already got the derivative of f prime of x. Let's take the derivative of g of x, and we're going to get a value for the slope when x is equal to 3 in both of these functions. So the derivative of k, since it's a constant, is 0. For e to the x minus 2, the derivative of e to a variable is always just itself. E to the x, right? The derivative of e to the x is e to the x. Derivative of e to the x minus 2 is e to the x minus 2. Times, then we have to apply the chain rule, times the derivative of the top. But the derivative of the top is just 1, because derivative of negative 2 is nothing. Derivative of x is 1. So we've got our really nice derivative here and here. Now let's plug 3 into both of these. So we know that e to the 3 minus 2, 3. E to the 3 minus 2 is e to the 1 must be equal to negative 2 times 3 minus h. So what we have right here is just with this equation alone, forget about this equation. With this equation alone, we can solve for h. So we're going to divide both sides by negative 2. 3 minus h equals negative e over 2. Then just to make life easy, I'm going to add h to the other side. Okay, so we're going to say plus h, just so we don't have to multiply by negative 1 at the end. 3 is equal to h minus e over 2 because it's a positive h. Last but not least, let's add the e over 2 to the other side. So h is equal to 3 plus e over 2. Now, that doesn't look the same as this, but we can get it there, right? Multiply 3, which is really 3 over 1. Let's get a common denominator. Multiply by 2 and by 2, and that's the same as 6 over 2. Now we add those together with a nice common denominator, and h is indeed e plus 6 over 2. Amazing. Okay, so we didn't actually need a system to get h. We were just able to get h with that one equation, but we're going to use this equation now to solve for k, which I see in part C. So let's do this. We're going to plug in e plus 6 over 2 for h and show that k equals this. Let's get a little bit more room here. So we're going to plug in, let's see, there's h, so we got negative 3 minus, I'm going to put this in parentheses, e plus 6 over 2, boom, like so. All of this is squared plus 2k is equal to e plus k. Okay. I'm going to start by subtract. You could do this either way, but I'm going to get k to the left side. So I'm going to subtract k, and then now we have k, and then minus all of this, minus 3 minus e plus 6 over 2 squared is equal to e. Okay, now let's move this over. We're going to add this to the other side, this entire expression. So it's k is equal to e plus 3 minus e plus 6 over 2, boom, boom, this entire thing squared. And that's my k. Now let's look at what it wanted us to get it equal to. E plus e squared over 4. Okay, so we're going to see if we FOIL this out and simplify everything, we get, I'll write it down, e plus e squared over 4. So hopefully this will simplify to e squared over 4 because we already got the e there. So we want e plus e squared over 4, just as a reminder. All right, now let's simplify. So we have this minus. What I'm going to do is I'm going to actually get like terms on this inside thing. I'm going to make this 6 over 2, the same as 3, minus e plus 6 over 2. And then I'm going to turn this into a plus and just distribute that negative to the e and to the 6. Now, as we add these together, look at that. The 6's cancel out, and we simply get a negative e over 2 squared. Starting to look a lot better. And then if we square this, we get e squared over 4 plus that e that was chilling out there before. And we have now confirmed that k is indeed equal to e plus e squared over 4. That's how you do it. Done. Number 5, show that sine of 2x plus cosine of 2x minus 1 equals 2 sine of x times cosine of x minus sine of x. Now, you can do this one of two ways. You could either remember the double angle identities for sine and cosine, or you can use the angle addition formulas. Therefore, then you don't have to memorize the double angle identities in addition. I'm going to go that way, okay, just so we have less memorization involved. So if you remember, sine of an angle plus an angle is equal to sine of the first angle times cosine of the second angle. And if this is plus, it's also going to be plus again. Sine of the other angle, okay, and it's x and x this time, so it's kind of interchangeable, times cosine. So we're doing here sine of the second angle times cosine of the first angle. But again, they're both x. So you can see you can kind of derive the double angle identity, sine of x, cosine of x times 2, okay? So this is going to equal 2 sine of x, cosine of x. So we got that one. Now, what about cosine of x plus x? So this angle addition formula is going to be cosine of the first angle times cosine of the second angle, which is also x here, minus, so when this is plus for the cosine angle someone, it's going to be a difference, minus sine of the first angle times sine of the second angle. So what do we end up with? We end up with cosine squared x minus sine squared x. So we end up with this nice double angle identity, but we just kind of derived it from scratch. So now we have this represents, can be subbed in for this. This can be subbed in for this. Okay, so let's plug those in, and then we'll kind of finish it off, and hopefully we're going to get to that side next. So now we have, let's write out 2 sine of x cosine of x plus cosine squared x minus sine squared x. Again, I'm replacing these two with these two, minus 1, and we've got all of this on that side. Okay, so where can we go from here? Now, another identity I'm going to leverage here, since I don't see any like 1 on this side or anything like that. Another identity we can leverage is sine squared. Okay, this is one of our nice Pythagorean identities. Sine squared plus cosine squared is equal to 1. So I can actually plug this in for 1, and then we can simplify it a little bit more. So we're going to write this out again. 2 sine of x cosine of x. Whoops. Sorry, my thing is glitching a little bit. Cosine of x plus cosine squared x minus sine squared x. And then minus, instead of 1, I'm going to plug this in. I'm going to go ahead and distribute that minus to both of these pieces just to save a little time. So we have minus sine squared x minus cosine squared x. Okay, so now we can take a quick look at this, and we can see that we've got a positive of that, a negative of that. Those are going to cancel out. And now we can simplify a little bit further. These two are both negative. They're going to add together. So now we have 2 sine of x cosine of x minus 2 sine squared of x. And this now looks pretty similar because look what we can factor out. They both have a 2 sine of x. So I can factor that out. Let's write it up here so we can see it all together. We got 2 sine of x, factor it out, times, when I pull it out of this expression, I just have cosine of x left. When I pull it out of this one, I have a single sine of x left, negative. And guess what? That is equivalent to the right side. So we just proved that identity, and that's how you do it. Okay, now let's get to part B. So then it says, hence or otherwise, solve this plus this minus this plus cosine of x minus sine of x is equal to 0. Okay, so now let's go ahead and solve this equation. Now we're going to get the values of theta for this equation. Let's move up here so we have a little bit more room for part B. Okay, so I think we're going to use pieces of what we did up here in order to solve this, because we have the double angle sine of 2x, double angle that cosine of 2x. So we're going to plug in and try and simplify everything and see if we can solve this equation, everything set equal to 0. So once again, we have sine of 2x is equal to 2 sine of x cosine of x. I'm going to write that out. And then, as I already mentioned before, cosine of 2x is equal to cosine squared minus sine squared. So we're going to say plus cosine squared x minus sine squared x. And for the 1, I'm actually going to go ahead and plug in again sine squared plus cosine squared. So we got minus sine squared x, right? Because again, I'm plugging this in. I'm going to distribute that negative to both of these because it's minus 1. So we've got minus sine squared minus cosine. Oops, cosine. Hold on, let me fix that. Cosine squared x. And then we got plus cosine minus sine is equal to 0. Plus cosine x minus sine of x is the log what? Is equal to 0. Okay. Now let's see where we can take it from here. So we've got this positive cosine squared x, again, boom, and those two cancel out. These two kind of can come together as a like term. So let's put this together here. So we got 2 sine of x cosine of x minus 2 sine squared x, right? Those add together. And then we also have plus cosine minus sine. So we got plus cosine of x minus sine of x is all equal to 0. Now, this is kind of an interesting situation. When you have 4 terms, a lot of times what we'll do generally when we're factoring is try to do factoring by grouping. So let's see if we can do that here. And all I'm going to do is with these 2 in the front, I'm going to see if there's any GCF. And we already know from part A that there is a GCF, right? We can factor out 2 sine of x. And what's interesting is when we factor that out, we now have cosine of x minus a single sine of x, which is the same thing that we have here, right? We have cosine of x minus sine of x. So why did I put a 1 in front of this expression? Well, I can always do that. It doesn't change anything to multiply by 1. But now you can see we have the same term here and here. And when we're doing factoring by grouping, you basically factor out that entire expression, cosine of x minus sine of x, times, and then it's times the sum of these two. Okay, so now it's 2, it's kind of like the remaining pieces, 2 sine of x plus 1 is equal to 0. And now in factor form, now we can actually solve this. So we're trying to figure out when this is going to go to 0 or when this is going to go to 0. So I can just set 2 equations here. Cosine of x minus sine of x is equal to 0. We have to solve that. And then we also have to solve 2 sine of x plus 1 is equal to 0. So let's solve both of these right now. If I add sine of x to the other side, I've now got cosine of x is equal to sine of x. So really what this one is asking is, when is cosine and sine going to be the same? Well, the place, if you remember the unit circle where both of those are going to return the same value, is at 45 degrees or pi-4 radians. That's where they're both going to return positive rad 2 over 2. Or we have in the third quadrant, they're both going to return a negative rad 2 over 2. And that's going to be at 5 pi-4. So if we're doing it in radians right now, we have our first 2 answers. We have pi-4 and we have 5 pi-4, right? Here would be 7 pi-4, here would be 3 pi-4 if you remember the unit circle. But those would not give you correct answers here. Cosine of x would not equal sine of x because in quadrant 2, cosine is negative, sine is positive. Likewise, in quadrant 4, cosine is positive, sine is negative. But we need them to be the exact same. Okay, and then we also get some more solutions here. Again, when 2 sine of x plus 1 is equal to 0, we can isolate. We can subtract 1. Let's get some more room up here. We can subtract 1. 2 sine of x is equal to negative 1 divided by 2. Sine of x is equal to negative 1/2. So when is sine of x equal to negative 1/2? First of all, sine is negative in quadrants 3 and 4. And when are we getting a 1/2, right? It's at that 30-degree measure, that reference angle of 30 degrees, or pi 6 radians, okay? So at positive pi 6 and at 5 pi 6, we're getting positive 1/2. So what are the equivalents down here and here? It would be 7 pi 6 and 11 pi 6. Again, if you need a refresh, you can look back at the unit circle, but I like to have all those values memorized just in general. 7 pi 6 and 11 pi 6. And these are going to be your 4 solutions for part B. That's how you do it. Done. Number 6, it is given that cosecant of theta, which we're going to write as cosecant of theta, is equal to 3/2, where theta is in between pi halves and 3 pi halves. By the way, just so you remember on the unit circle, this would be pi halves up here. This would be 3 pi halves up here. So we're talking about quadrants 2 and 3. And it says find the exact value of cotangent of theta. Okay, so we know what's in one of these 2 quadrants. Now, they're saying that cosecant is positive. All right. If you remember, cosecant is actually the inverse of, or the reciprocal, I should say, of sine. So cosecant is going to be positive where sine is positive. Of these 2 quadrants, sine is positive up here because it also equates to, it's equivalent to the y value in the unit circle. Y is positive in quadrant 2, not quadrant 3. So with this limitation plus this limitation, we know we're in quadrant 2. And now we can use this information to kind of draw out a representative triangle. So I'll draw out a little nicer one with some nice straight lines so you can see it a little bit better as I'm doing this problem. So we got this nice thing. And what is cosecant, right? We know that sine is opposite over hypotenuse from SOHCAHTOA. Okay, opposite over hypotenuse. So cosecant is the reciprocal is hypotenuse over opposite. So we're going to draw a little representative triangle. I'm not going to make it so perfect that it is like exactly looks like represents as 3 and the 2, but we know my angle theta is going to be here. It's on the inside of the triangle touching the origin always. And then so again, this is hypotenuse is 3, opposite is 2. Okay? And the only side we don't have is this side. Now, we're in quadrant 2. This is the x side, right? That's negative in quadrant 2. So I know this value is going to be negative, but what is the value? How do I figure it out? Pythagorean theorem, right? I'm called this a. We know that a squared plus b squared, which is 2, is equal to c squared, which is 3 squared. So we now know that a squared plus 4 is equal to 9. Subtract 4 from both sides. A squared is equal to 5. Square root. Guess what? This a side is equal to rad 5. Now we can solve this question. They said, what is cotangent of theta? Well, that's the reciprocal of tangent. So let's figure out tangent first. Tangent is opposite over the adjacent side of this triangle. So tangent would be 2 over rad 5, but cotangent is the reciprocal. Okay, oh, and by the way, sorry, I forgot one thing. This is negative rad 5. Remember I said this is going to be a negative value. My bad. So that's negative rad 5. So tangent would be 2 over negative rad 5, but cotangent is the reciprocal of this, which is negative rad 5 over 2. That's the final answer. That's how you do it. Done. Okay, for this one, we have this quartic equation. It says 2 of the roots are a plus bi and b plus ai, where a and b are integers, okay? So find the possible values of a. So what we got to remember with these root solutions is that they always come in conjugate pairs. So if a plus bi is a solution, so is a minus bi. And if b plus ai is a solution, so is b minus ai. And these are all the solutions because this is quartic, and that means there are 4 solutions. These are the 4 solutions. That's it, nothing else. So what we can then do is we can get a different representation of this quartic function. What we can do is we can say, if I do it kind of in factored form, z minus a plus bi, I'll distribute that negative, so z minus a minus bi, Okay, this is one of the factors. And then we also have z minus this, z minus a plus bi. Again, remember, I'm distributing that negative. That turns that positive. Over here, I have z minus b minus ai. And then over here, I have z minus b plus ai. And now we have a lot of work to do, but if we can start to FOIL this out and get it to look equivalent to this, we can start to figure out possible values of a as the question asks. So we're going to start to FOIL this out. So we're going to say z times z, and I'm going to just do these two together, and then we'll FOIL the final results, because when you FOIL these two, believe it or not, you're actually going to get a quadratic. And same with this, the imaginary terms will cancel out with these conjugates. So check this out. We got z times z, which is z squared, z times negative a z, and then z times bi, which is plus bi z. Then we got here negative az. Notice how I'm moving it one space over. This is just to line up the terms with like terms, going to make it easier at the end. Then we got plus a squared, and then we've got minus abi. Down here, we've got negative biz, negative, or positive, sorry, excuse me, abi. I'll write it like this, just so it matches up exactly with that. And then minus b squared I squared, which is plus b squared, because I squared is -1, so it's going to flip that sign. And what you can see is, here, let's make this a little smaller. What you can see is this is going to cancel out with this, and likewise, this is going to cancel out with this. So now as we add this together, we get z squared minus 2az plus, what is that, a squared plus b squared. Okay, and normally it'd only be 3 terms, but because these are both constants and we can't add them together, it's going to be 4. But anyways, that's what we get there. Now let's do this one. So again, we have z squared minus bz, and then we have plus aiz. Over here, we have negative bz, and then we have plus b squared, and then we have minus, let's make that abi. And then finally, we have minus aiz. We have plus abi. And then last but not least, negative ai times positive ai is negative a squared I squared, which is positive a squared, once again, because I squared is -1. So what can we cancel out here? Once again, these imaginary terms are gone, which is, if you're doing that, you're on the right track. And these are gone as well. So now over here, we have z squared minus 2bz. We have, let's see, plus, I'm going to say a squared first, just to have it in the same order, plus a squared plus b squared. Okay. So now we have this nearly in quartic form. All we got to do is FOIL this out, and then we can kind of start to match up coefficients, create equations that way. So let's take it from here. As we multiply this out, we got z to the 4th. Then we've got minus, right? So first we have this, then we have minus, this is going to take a crazy amount of time, minus 2bz to the 6th. And then we've got plus az squared. And then coming all the way here, we've got plus bz squared. Okay, then we're going to continue multiplying here. Now we have negative 2az cubed. Okay, right? Is that z squared? Yeah. Negative 2az cubed. Oh, wait, I think I made a mistake here. This was supposed to be z to the 4th, negative 2bz to the 3rd. Sorry. That's supposed to be to the 3rd. There's a mistake there. Yeah, because these should match up, at least in degree. Then we've got negative 2 times negative 2 is positive 4, ab z squared. Then we've got this times this, which is negative 2a cubed z. Hold on, am I doing that right? Negative 2a cubed z. I did this right, b squared z squared. Yeah, I got that right. But apparently that doesn't match up, but it's all good. And then we have over here minus 2ab squared z. Okay. All right, next we've got the a squared multiplying. So we've got z squared a squared. Let's see, plus z squared. Yeah, I'll say a squared z squared. And then we've got minus, what is that? 2a squared b. Oh my gosh, this is so crazy. Z. And then we got here, we've got plus a to the fourth, and then plus a squared b squared. Okay, the last one, we've got b squared z squared minus 2b cubed z plus a squared b squared plus b to the fourth. Now, there may be a more efficient way to do this by all means, okay? This is my first time doing this test and looking at these questions, so there very well may be a much easier way. Now, I don't know if we need to combine everything, but let's see. What we could probably do, see, okay, I already see here, these are the only z cubed terms. Let me just double check. Yeah. So I can actually just take these two and say negative, here, check this out, negative 2b z cubed minus 2a z cubed is equal to 4z cubed, right? Those are the z cubed terms. So we can now divide everything by z cubed, and I can say negative 2b minus 2a is equal to 4. Divide everything by negative 2, b plus a is equal to negative 2. Okay, so now we have one equation for b and a. If we can get a second equation, we can knock this out. So let's see here. Let's see what else is easy that we don't have to do a ton of work. I have a z term here, a z term here. I have another z term there. Well, let's look at the z squared, and then I have another z term there. Let's see the z squared. Or no, check this out. For the constants, oh, that's kind of a mess though. For the constants, I have a to the fourth, a squared, b squared, and b to the fourth is equal to 400. That is a perfect square. Actually, wait, that can work. Let's do that one. So we got that equation up here. So again, you can see here, I'll color code it for you guys. This is what I'm talking about. We've got a to the fourth, no variable, a squared, b squared, no variable, b to the fourth. We have another a squared, b squared. So those are all my constant terms, and that's going to match up with 400. So check this out. We've got, let's write it up here, a to the fourth plus 2a squared, b squared, and then plus b to the fourth is equal to 400. So this is actually pretty good because this is a perfect square. This is literally a squared plus b squared squared. If you recognize that that's a perfect square, this gets a lot easier because if you FOIL this out, you'll get exactly that for the middle term and these for the end term. So now that I have this is equal to 400, I can square root both sides like so, and I got a squared plus b squared is equal to 20. So now we have a nice little system. I know that b plus a is equal to negative 2, and then I've got a squared plus b squared is equal to 20. So let's see what we can do with this. If we can do a little substitution. So I'm going to say that a is equal to negative 2 minus b, and then we're going to substitute this in here, and we're going to try and solve for a. Or no, wait, what am I doing? That would no, let's do it the other way. We need to isolate b and then plug in the a term because we want to solve for e. So b, let's write that again. B is equal to negative 2 minus a. So we're going to sub this in for b right here. So now we have a squared plus negative 2 minus a squared is equal to 20. And we got a nice little quadratic here. So we got a squared. If you FOIL this out, you're going to have 4, and then you're going to have 2a and 2a, which is 4a, and then you're going to have plus a squared is equal to 20. Let's combine everything. So we got 2a squared plus 4a, and then we're going to minus the 20 over minus 16 is equal to 0. Let's keep it going. We're going to divide everything by 2 to simplify. A squared plus 2a minus 8 equals 0. Look at this. This is a factorable. What multiplies to negative 8 adds to 2, positive 4, negative 2. And there are my two values for a. A could be negative 4 or 2. Let me just make sure there's no restrictions or anything. But yeah, it can be any integer. So I think those are both viable answers, possible values. That's how you do it. Done. So here they want us to use L'Hopital's rule, but remember the first thing you have to do to apply L'Hopital's rule is verify that the original direct substitution of 0 gives you indeterminate form, aka 0 over 0. Well, we know that tangent of 0 is definitely 0. And arctangent of 0, right, we're going to be like 2 times 0, is also going to be 0. It is indeterminate. It qualifies. Now let's take the derivative of the top. If you guys remember, the derivative of arctan is 1 over 1 plus x squared. That's my entire x. So 2x squared is 4x squared. But don't forget the chain rule. So then times the derivative of the inside of 2x, which is 2, over the derivative of tangent is secant squared of 3x. Don't forget the chain rule. And we multiply by the derivative of the inside, which is 3. Now let's plug in again and see what we get. So when I plug in 0 here, I get 1 plus 0, which is 0. 1 plus 0, which is 1. 2 over 1 is 2 on top. Down here, we plug in 0. So we get 3 times secant squared of 0. So cosine of 0 is 1. Secant is the inverse of cosine, reciprocal of cosine, excuse me, but reciprocal of 1 is still 1. So secant squared of 0 is just 1 times 3 is 3. 2/3 is the winner. That's how you do it. Done. A farmer has 6 sheep pens arranged in a grid with 3 rows and 2 columns in the following diagram. 5 sheep are to be placed in the pens, and each pen is large enough to hold all the sheep. Amber and Brownie are known to fight. So find the number of ways placing the sheep in the pens in the following cases. So each pen is large enough to contain 5 of the sheep, but Amber and Brownie must not be placed in the same pen. Okay, so if we think about all these different pens, numbered 1, 2, 3, 4, 5, and 6. Let's think about it like this. So we have basically 6 different ways that we can place Amber. We can place Amber in 1, 2, 3, 4, 5, or 6. So depending on where Amber is placed, okay, so Amber is placed in any of one of these. So in each of these cases, let's look at the options for B. Well, B can't be in 1 when Amber's in 1. So how many choices does B have in this case? 5. And then what about C, D, and E? Well, they can be placed anywhere, and there's enough room in any of the pens for all the sheep. So they have 6 options, 6 options, and 6 options. So when Amber's in 1, we've got 5 times 6 times 6 times 6, many options. And what is that? 216 times 5 is 1,080. But then we've got 5 other ways that we could do this, right? So again, when Amber is in 2, B again has 5 options, 1, 3, 4, 5, and 6. So we're going to have the same thing. And then again, C, D, and E are still going to have those 6 options. They're going to have total freedom and flexibility. So as you can see, we kind of repeat this count for all 6 placements of A. And what do we end up have happening is we have 6 times 1,080, which is 6,480. So that's how you do part A. Now, when it comes to part B, now we're changing things. We're saying each pen may only contain 1 sheep. So it's no longer anybody can go anywhere, okay? But now it says Amber and Brownie must not be placed in pens which share a boundary. So let's talk about that. Let's move up here. So for example, we've got kind of like 2 different interesting scenarios. If Amber is placed here, or in 1, for example, Brownie can't be in 3 or 2. Likewise, if Amber is placed in 2, Brownie can't be here or here. So these are in the corner spots. The same situation will be happening here. If A is here, right, nothing, B can't be there or there. And then if A is in 6, B can't be here or here. So these are the restrictions. So when A is in the corner spot, okay, B is restricted from 2 spots, but can go in the remaining, and can't obviously go in 1 because that's where, in the same spot as A, because only 1 per pen. So B will have 3 options, okay? And then what about D and E? Sorry, D, C, D, and E, excuse me. C, D, and E. Okay, so Amber's in 1. Brownie has 3 options. But then once we've assigned Brownie, the rest of them have 4 options, 3 options, and 2 options. And why do we count down like this? It's because, once it's kind of like once we've assigned C to one of the remaining 4, then there's only 3 left, and there's only 2 left, etc. So this is the scenario for all the corner spots. We basically have 3 times 3, which is 9, times 4 is 36, times 2 is 72. But how many corner spots do we have? 1, 2, 3, 4. So we're going to have that same number of options for each of those corner spots, which is 4. So if we get 72 times 4 for all the corner spots, we get a total of 288. But the other 2 options are if A is in a middle spot, like 3 or 4. So if A is here, then Brownie is very restricted. Can't go here, can't go here, can't go here. So then in that case, Brownie only has 2 options. Okay, but once again, once brownie is placed, nothing else changes for C, D, and E. Now C, that then 2 have been placed, and then C can go wherever. Any of 4 spots, any of 3 spots for D, and any of 2 spots for E. So what is this? We have 2, 8, 24 times 2 is 48. And since there's 2 middle spots, we multiply that by 2, and we get 96. Last but not least, we're going to add 288 and 96. And this is going to be 4, carry the 117, 18, carry the 1, and we've got 384 in total. That's your answer to B. Your answer to A, once again, was 6,000 and, let me double check. What was it? 6,000, 480. Whoops. And that's how you do it. Done.